Hello, my name's Bob Willis and welcome to Defect of the Month. This month I'd like to talk about underfill and voids, or voids in underfill. Now, underfill is a material which was introduced into the industry basically to control or define equal out the expansion coefficient difference between materials. So if you've got a component which is mounted on a PCB, like a flip chip, a very large area array package, you might use an underfill to even out the difference in expansion rate between the solder, which is making that interconnection, the body of the component, and the PCB. So putting a material directly underneath the package tends to even out that expansion and contraction, thus improving the reliability of the parts. That's the original concept. Underfills come in two different types. One that is a no-flow underfill, one that you can rework. You can get other methods of bonding parts to PCBs, which are generally quite often used today because they're a cheaper solution. But if we talk about traditional underfill material of whatever type, what you want or what you don't want is voids. Because if you've got voids, then you're not getting the same characteristic on other solder joints that might be present. So you want to try and avoid differences in expansion and possibly increasing or decreasing the reliability of the product. In addition, what you want to try and do is eliminate voids because of flux residues or other contamination that may be present underneath the component. If you imagine that when you're soldering or even reworking a BGA, there's going to be flux present around the solder sphere joint between the component and the PCB. So voids in that particular area, particularly if the flux left behind is active, you might potentially get some corrosion effects that might occur. But you're not actually achieving what you want, which is a homogeneous coverage of the balls, the PCB, and sealing that gap between the package and the PCB. Some other companies use underfill materials to increase the mechanical strength in terms of drop performance. So if you take a unit that components have been mounted to, if you put underfill, generally speaking, if you drop a product, it's going to last longer because of that underfill material. I would suggest that a lot of these applications now use corner bumping as an alternative to underfill because it's a cheaper and simpler process and allows easier rework. However, fundamentally, those two things are true. So try and reduce. You may not be able to eliminate voids totally, but you've got to think about that as an issue. So why do voids occur? Well, voids can occur during the curing process because of some volatile material which is present in the solder mask surface. That's one of the reasons why quite often underfill process is directly after reflow when the board is still theoretically in a dry state. And I say theoretically because just reflowing a product won't get rid of all the moisture. So some companies will bake a PCB right at the very start to eliminate outgassing from the solder mask, but they may do the underfill process very close to the end of the reflow process to get the optimum performance, if you like. If not, if you're leaving it, then you've got to think about what the moisture content might be and whether that's actually going to have an effect. Now, some solder masks, if you test them, what you can do is you can just put a droplet of oil on the surface, heat the board up, and look underneath where the oil is. And it's the same as my old outgassing test that I've used many times in the industry. Just that oil on the surface of the resist will show you if any volatile materials are coming out. And I have been able to demonstrate that on a few occasions in the past. So hopefully you don't have any voids. There's not really any international standards to say what voids are acceptable and unacceptable, and that's something you need to confirm with your supplier or your manufacturer. and possibly test products to see whether voiding is an issue to you in your application or not. Thank you for listening to Defect of the Month. My name's Bob Willis, and hopefully you'll be joining us for more Defect of the Months in the coming weeks. Thank you very much.